Algebra 2 pre-AP. If you're in regular Algebra 2, you want to watch the other lesson. So, we're going to talk about rational exponents. So, exponents that are fractions, right? That's a fancy way of saying fraction exponent. And for our opening exercise, we're going to talk about, hey, what do we think the value of 2 to the 1/2 power is? And really, all we can do to figure that out is we can compare it to some stuff that we know, right? We know that 2 to the 0 power, we also know that 2 to the first power is 2, right? So then it seems to me then that it must be the case that 2 to the 1/2 power is somewhere in between 1 and 2. About the closest I can get, just kind of guessing at it, right? I know it's between 1 and 2. Where exactly? I don't know. It's 1 point something. But we can't know exactly what it is, really, without the use of a graphing utility or a calculator, period. But let's look at and let's analyze a graph just to see what does 2 to the x power do. So in order to analyze this graph, I'm going to set up a table with an input value of x, and my output will be f of x. And it says it wants each integer value from -2 to 5. So we're going to go by steps: -2, -1, 0, 1, 2, 3, 4, and 5. So f of x is 2 to the x power. When I input -2, that's 2 to the -2 power, right? 2 to the -2 power is the same thing as 1 over 2 to the +2 power, which is 1/4. Which means that this is 1 over 2 to the -1 power, which is 1 over 2 to the first power. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. Let's graph it. Don't giraffe it, just graph it. All right. So at -2, we're at 1/4. So way close to the x-axis, right? At -1, we're at 1/2, which is still pretty darn close to the x-axis. At 0, we hit 1, and we notice that these are in units of 2. So 1 should be somewhere, I don't know, that's probably not perfect. That's where I'm putting my 1. I made my 1. At 1, I know, my jokes are bad today. Not bad meaning bad, but bad meaning good. Okay, 2, we're at 4. And at 3, we're at 8. At 4, when x equals 4, y is equal to 16. And when x is equal to 5, y, or f of x, is equal to 32. We'll go ahead and connect this with a smooth curve. Oh, it's so smooth. You don't want this curve talking to your girl. Okay? It's way too smooth. Okay? Alrighty. Alright, there it is. Yay! We did some graphing. So we know what this looks like. A little segue into exponential functions, right? This is exponential growth, right? This would model some sort of exponential growth. You might remember from Algebra 1. You should have, at some point in time, explored exponential functions. So, there you go. And we'll move right along into the second. All right, moving right along. So, we already did this, right? We found two consecutive integers that are under an overestimate. Our first ones were 2 to the 0 and 2 to the first power. There we go. So those are consecutive. They are an under and over estimate, right? So let's see. Does it look like 2 to the 1/2 power is halfway between the integers that we specify? Well, let's see. We're at 0 here, right? And we're at 1 here. So halfway in between is here. What are we looking at when we're halfway in between? It looks like we're right there, but it's not quite on. It's not exactly halfway, because if it was exactly halfway, it would be right where the crosshairs meet, right? For each of those. So not quite. About. It looks like it's close. It's close, but not quite. And let's take a little bit of a segue into using technology to do this, okay? So let's look at 2 to the 1/2 power. Alright? 2 to the 1/2 power. You can actually put that in your calculator. Some of you, if you don't have the operating system that puts it up into the power like that, you might have to write it like this, put it in parentheses. And you'll get the same thing. Sometimes, so if you have like an 83 calculator, you might have to, it'll say 2 and then the caret. You have to put that 1/2 in parentheses or you won't get the right answer. Alright? So it's approximately 1.414. Cool. That's what it is, right? Amazing. Moving on. That's how to calculate it in your calculator. We'll talk a little bit more about the calculator here in a second. So if we were going to estimate it, so we already cheated. We already looked at what the actual value was. But if we were going to estimate it using this graph, let's see, we're at 1, 0.1, 0.2, 0.3, 0.4. So we would say that 2 to the 1/2 power looks to be, from our graph, approximately 1.4, right? If we're going to use the graph, it looks like maybe a little more, 1.41 or something, or we're not sure, right? So I'm going to say around 1.41, 1.4. Keep sticking with me, right? And we're just going to use the graph. What about 2 to the 1/3? If we're going to use this graph for 2 to the 1/3, the way that I would do that is I would go to what 1/3 is in a decimal, right? So 1/3 decimal-wise is 0.333. So let's just go to 0.3. We're estimating, so it's all right. 1, 2, 3. So we're going to start here. And we'll look at what f of x is when x is 0.3. And it looks like that's going to be 1.12. Something like that, right? It looks like it's approximately 1.1. 1.2. I don't know why I said it. And let's go ahead and put that in our calculator and see how we did there. 2 to the 1/3 power. Yeah, it's around 1.2. So this graph is accurate. That's all that says, right? It says that our graph is essentially accurate. Yay! All right, now we're going to head right into talking about writing rational exponents as radicals. They're the same thing. Okay? So, what's the fourth root of 16? What we're being asked for is that. What times itself 4 times is 16? It's 2. Hey, how about the cube root of 125? That's what we're being asked for. That is going to be 5. Hey, how about the 5th root of 100 G's? 10. Okay. That was a 10. It's just how I am. Yes.
So, are you reading something like that? So, gave us like a power that like that. Like, how do you know what's inside?
On the side, so I'm saying there's a number that if I multiply itself, if I multiply it times itself, that amount of times I get this. All right, here we go. Let's evaluate each one of these expressions, okay? What is the 4th root of 81? So something times itself 4 times. 3. Yep. So that's 3. And at this point in time, I would like to introduce our new property of exponents, which tells us that if I have some nth root of a to the m, that is going to be a to the m divided by n. Whoa. Set n and row 2. There we go. Hey, kind of. Only if n is equal to 2. And there's a corollary to that, which says that if I have some nth root of a, that is going to be a to the 1 over n, right? Because that data is the first part. Okay? So that's the main property we're going to use in lessons 3 and 4. So that means that I could write this as 81 to the 1/4 power. I could do that too. Let's go ahead and go to our handy dandy calculators and look at both of those values, right? So remember, I can calculate the 4th root of 81 by going to math. If you have the latest operating system, and I would hit 5, I would go down to this one, and I can hit 5. Wait, what was that? Oh, 4. 4 and 81, and it picked it up. But I told you that the same thing would be saying 81 raised to the 1/4 power. The two things are equivalent. All right. Let's go back. So then we can rewrite this one as, well, first of all, so let's call this 32 to the 1/5 power. What is the 5th root of 32? It's 2. with this one, remember we have a property of radicals that we learned, that if we had some nth root of A times the same root, the nth root of B, that's the same thing as the nth root of A times B. Right? We learned that last semester. So this would be the third root of 9 times 3, which is the cube root of 27, which we all know is 3. We shall do the same thing with this group of numbers. So this would be equivalent to the fourth root of 25 times 100 times 4. 25 times 4 is 100, and 100 times 100 is 10,000. And the fourth root of 10,000, just count them zeros, 1, 2, 3, 4, that means that must be 10 to the fourth power, right? Sorry, it's 10, sorry, my bad. The answer is 10, but 10,000 is 10 to the fourth power. Okay. So for this next one, we're going to be converting rational exponents into radical expressions. Okay? So 2 to the 3/4 power is going to be, if we're using that property, 2 to the 3/4 power is going to be the fourth root of 2 to the third. Putting that m and that n in the right place. So let's do the same thing here. 3 to the 1/2 power. Well, that's 3 to the first power, right? And then the 2. Remember, so it's your denominator that goes on the outside of your time. That's all you have to remember. Denominator goes on the outside. Numerator goes on the inside. 11 to the 1/5 power. You guessed it, it's the 5th root of 11. And that's not all. There's more. If you act now, we'll do the next page. Okay. So this is the 5th root of 1/4. And darn it, we can't just leave it like that. We gotta simplify it. So this is the 5th root of 1 over the 5th root of 4, which is 1 over the 5th root of 4. And remember what we learned, that it's just not polite. So the radicals in your denominator. And in order to get rid of them, what we're going to do is rationalize our denominator. Remember, we would do that by multiplying by some clever number 1. Our clever number 1 is the 5th root of 4 over the 5th root of 4, right? This is how we rationalize our denominator. So that becomes the 5th root of 4, and the 5th root of 4 times the 5th root of 4 is 4. It's 4. Yeah. So sorry, my clever number 1 was wrong. So, and what I'm going to do is I'm going to actually write this as 1 over 4 to the 1/5 power. What would I need to multiply 1/5 by to get 1? 5, right? So in this case, if I'm going to rationalize this, my clever number has to be 4 to the 5th power. So that becomes 4 to the 5th over 4 to the 1/5 times 4 to the 5th. This is going to get rid of our radical, okay? So that's 4 to the 5th over 4 to the 4th first. We're adding, right? Dang it, I chose the wrong one again. So this should be, so we're going to write this again as, and then we're going to multiply this by, sorry, this should be 4/5 over 4 to the 4/5. There we go. Now we got this thing rationalized. So I'm going to add these exponents and I get 4 to the 1st power. And then we can rewrite it as a radical, right? So this is the 5th root of 4 to the 4th over 4, which is the 5th root of, yeah, lots of numbers. Wait till we put variables in, it'll be good. So 256 over 4. Just curious if 256 has a 5th root. Nope. So that's it. We did it. That's about as nasty as that gets. So there. All right. Here we go. 10th root of 6. Much better. I'm not actually sure why Eureka put a weird problem like that in the middle. I think they wanted us to leave it as the 5th root of 1/4. But that would mean that I have a radical in my denominator, and I just can't. So I had to rationalize it. Sorry I did it wrong the first 3 times. Here we go. I apologize. Alright, let's simplify this all the way. And that's the key root of the square root of 8. Guys, remember, you don't have to put the 2 there if it's a square root, but I'm doing it just so you can see what's going on. Alright. So this is the square root of 4 to the 5th. And that is the square root of 1024. And hey, does 1024 have a square root? Indeed it does. So that's 32. All right, moving on. This looks like the cube root of 1/8 to the 5th power. Which then is the cube root of 1 to the 5th over 8 to the 5th, right? We got to raise both our numerator and our denominator to the 5th power. So this becomes the cube root of 1 over 32,768 That's what 8 to the 5th power is. Hey, that is, I'm going to just do every little step. That's the cube root of 1 over the cube root of 32,768. It turns out that 32,768. It turns out that 32,768 to the 1/3 power is the thing. It's 32. So let's go ahead and put that value in here. So that's 1/32. Woo! I got this one. Smile with the rising sun. Hey, we're gonna have to use this property, right? Or it seems like that's what's going on, right? You could justify it like that. Or we could use algebra to justify it, right? No, you're right. We could. I was just shaking my head. I think Sydney's writing a novel back there. What? Are you a book? So, I'm just texting them my essay real quick. My thesis is pretty sweet.
That means it's my life.
Okay. Now I'll use algebra instead. And if this is my denominator, if I multiply both sides by 2 to the 1/2 power, right? That's what makes so the 2 to the 1/2 power goes away in my denominator, and I wind up with 2 to the 1/2 times 2 to the negative 1/2 equal to 1, right? Hey, what do we do with these exponents? We add them. So that becomes 2 to the 0. Hey, look at that. We used algebra to show that that was true. That was so special. Okay. Let's look at some negative radicals. Yay! All right, so that's going to become 1 over 4 to the 3/2 power, right? So that's 1 over the square root of 4 to the 3rd. 4 to the 3rd is 64. All right. How about 2 to the negative 27 to the negative 2/3 power? That's 1 over 27 to the positive 2/3 power, which turns out to be 1 over the cube root of 27 squared. That's 1 over the cube root of 27 squared is, survey says, 729. Does 729 have a cube root? It sure does. It's 9. Beautiful. Sorry about this 3. If it was in Sparta, they'd have thrown it off the wing. Yeah. Change what to one? Yeah, you can't just multiply stuff. Well, if you yay, I think this is our last one. 1 divided by 1/4 to the 1/2 power turns out to be 1 divided by the square root of 1/4, which turns out to be 1 divided by the square root of 1 over the square root of 4, which is 1 divided by 1/2. I flip and I multiply, and I land up with 2. That is crazy. Right? 1/4 to the negative 1/2 power is 2. Whoa. That's weird. The homework is, it's very important for you to be good at this stuff, so I did give you a little bit. And it's 3 through 6, 11, and 14.